Hey everyone, so like Tim, I also work here at Workframe, and just a little bit of background. We've recently been exploring how to use GraphQL because of our iOS application, and that fortunately had Apollo available to it, so we were able to dive in there. And then once we started to consider how we might be able to do this for our web app, things got a little bit harder. So I'm going to go over a library that we're also open sourcing today called Artemis, which is a small ClojureScript GraphQL client, and it is pretty heavily inspired by Apollo, but it is not a wrapper or anything like that. It's pure ClojureScript, and some of the ideas that you'll see come directly from Clojure and the Clojure world, and that's kind of why we wanted to go with that approach. So in general, I think that the Clojure community has been a bit slow to adopt GraphQL, as Dom said earlier. I think a lot of it has to do with the fact that, you know, people feel comfortable with Clojure, and Clojure can actually do a lot, whether it's the core API itself, some of the core libraries that come along, or some of the open source libraries that are out there. Clojure is pretty powerful, and things like Datomic is pretty powerful, and you can accomplish a lot there. Nevertheless, like Licinia has shown us, the GraphQL spec itself is actually a strong suit, because it starts to remove some of the big questions that you end up asking yourself when you kind of roll your own with all of the things that Clojure puts out there. So you could definitely achieve a lot of the stuff that GraphQL gives you with Clojure, but we like the spec because it sort of allowed us to not think about these big questions and try to come up with solutions that are already baked into something like the GraphQL spec. In our case, at least on the ClojureScript side, and even on the server side as well, we're able to ignore that kind of stuff and just start writing code and write application type code that fits what we need and not have to worry about how to do some of these big, tough things. GraphQL, kind of, the ideas behind GraphQL already are there, and the community behind it is there too. So that was the motivation for coming up with this library as well as the other libraries that Tim presented. But before I go on and talk about Artemis, I do want to give a shout out to a couple other approaches out there, because again, Clojure is pretty open and you can do a lot of stuff with it, and a lot of people have already started that. So these are some good libraries that are out there that are in Clojure, in ClojureScript, that allow you to use GraphQL or GraphQL-like stuff. The first three are for GraphQL. The last one, DatSys, is actually not for GraphQL. It's a Datomic DataScript kind of connection architecture. And its hope is to give you some of the same things that GraphQL does, but entirely based off of Datomic. It's still a really good library though, and we did consider that initially too. So yeah, I won't go over Apollo too much because Dom covered that pretty well, but if you want to take a look at the JavaScript version of it, you can go to that link there. And it's a really popular library. It's got like 7,000 stars on GitHub now. I would say it's probably the leading JavaScript library. I mean, Relay's out there as well, but I feel like Apollo's really picked up steam over the last couple of months. And like I said, it has support for a bunch of clients, Android, iOS, and you can definitely use this in ClojureScript through JavaScript interop, but I don't think that's actually true, that last part there, for every UI framework, because when we started exploring it, it actually doesn't work that well for ClojureScript. To start, you have to do a lot of interop, which is the first kind of annoyance, but it works. The big problem, though, is that you're forced to use JavaScript data structures. And that's unfortunate, right? Because the big thing that Clojure offers you is data structures. That's what Clojure is all about. And writing ClojureScript without Eden is terrible. That doesn't make any sense. And so we found that Apollo actually doesn't fit for our UI framework, which is Reagent, but really any kind of ClojureScript framework in our opinion. So we set out to build a library that would give us some of the things that Apollo did without bringing the entire kitchen sink that Apollo does, and also while working really well with ClojureScript. And so that's what Artemis is. Just to kind of set those things out, we wanted it to be ideally written in ClojureScript, just ClojureScript. We wanted it to be small. Apollo is actually pretty big. They claim it's small, but it's pretty big. It's all broken up into separate modules, so you can include what you want, but the entire project is big. So we wanted it to be small, but at the same time extensible. I think that's one of the good things that Clojure has offered us, is different ways to extend our code and do different things. And so we wanted to stick with that paradigm. And we wanted it to be very simple. Have just a few ideas so that you could just get started with writing your code. Practically, however, we have a pretty small team here. So we didn't want it to be a big time sink. These are our first open source libraries, and we've spent the last couple of years working on the software that we use to sell, to run our business. And while we value open source and we're happy to contribute, we're again a small team and we can't have this be a time sink for us. We also have a lot of non-GraphQL code. Workframe itself has been around for about 2 years, software, maybe a little bit less. And in that time, we've developed a lot of code that is in GraphQL, and we wanted to be able to keep this code sitting beside that. We also wanted to make it easy for the whole team to understand. We're hiring, of course, and so that means new developers coming on board. And we didn't want this to be a big hurdle for them. We also needed it to directly address our specific business needs. And finally, we wanted to make it available to everyone in Clojure and directly to the Clojure community. So that's the whole motivation behind the open source efforts. So this is how you would basically do stuff with Artemis. So the main API is really just two functions, query and mutate. And like Apollo, you create a client and you call queries and mutations on that client. That is basically it. That's how it all works. Client, GraphQL query or mutate, and that's it. It's all kind of done in the spirit of simplicity. Again, we wanted this to be a very simple approach. And fortunately for us, the reason we're able to do something that is this simple is because, again, Clojure can do so much. And so we're able to leverage a lot of the things that Clojure already has baked in, and a lot of the community stuff that's out there too. So one of the big things, actually I would say the central thing to how Artemis works is channels, and core.async gives us that kind of ability. So GraphQL is all about querying some remote source for data, and that inherently means that there's a level of latency involved in getting that data. So Artemis uses core.async channels to provide an abstraction around query and mutation state as it's going across the wire. So in other words, Artemis will track the life of a query or mutation and then tell your code when something important happens by putting a message onto the channel. Important things are responses, of course, but also errors and different changes to the network. So the main idea is that everything is based on is that Artemis will tell you as important things happen so that you can respond to them. And that makes it really easy to, for example, render a UI that's based on network requests. So you can see here in the code that we simply call query, take off that query inside of our Go block, and then do something with the message that we're given. And the same thing would apply for mutations. They work exactly the same way. It's the same interface. Again, we aim for it to be simple and easy to understand. So as long as you understand how channels work and how to take stuff off channels, that's it. You understand Artemis. You also have to understand GraphQL, of course, but you already do now. So that's it. The real thing, though, is that if you were to use if you were to take just one time, that's not really useful. You're not going to get too many updates that way. And our UIs change constantly, right? We need to constantly re-render them. And so we want to be able to receive multiple updates. And so that's where channels really shine, and that's how Artemis is able to leverage these things. Artemis, when it creates a channel, or when it returns a channel from query or mutate, it's able to understand the life cycle of that entire channel, depending on what kind of query you're firing off. And depending on what things happen, it puts certain messages onto that channel, and then it automatically closes that channel at the exact time that it's supposed to do it. Again, that all depends on the type of query or mutation that you're trying to run. But Artemis knows that based on the information you provided. So it's really easy to do multiple updates by just looping over, by doing a go loop and looping over our messages that we receive on our channel. That's completely safe because we'll get our final when we close our channel, we'll get our final message, which is going to be nil. That's just a core.async construct. And the loop is done, and completely done. We don't have to worry about cleanup or anything like that. So essentially the idea is just loop over a channel and the messages that that channel provides, and Artemis will take care of providing the right messages at the right time. So what is a message? Well, a message is actually something that looks like that. It is basically a map that has a couple of keys for data and variables, as well as errors and some metadata. So data is really just going to be the result of your GraphQL query. Variables is the variables you send over, if you send over any, when executing a query. Errors is a sequence of error messages, which is again just the GraphQL spec-defined error messages, which apparently are not very well defined at all. But you will have a map that at the bare minimum has a message on it. And then you've got some metadata, in-flight and network status, and that kind of stuff is where you can really kind of make your UI responsive and do certain things. The combination of data, errors, and meta information makes it possible to consistently update your UI whenever there's any kind of update to the state or the life of a particular query. At Workframe, we use Reagent, so I'm going to run through an example that is also done in Reagent, but you can use Artemis with any ClojureScript-based library. You could use it with Rum, you could use it with Ohm, I think, and you could use it with just plain JavaScript interop if you want to go that way. It's just channels, just query mutate channel, and then you do whatever you want in response to taking off that channel. So let me see if I can get this application running. Building ClojureScript right now, so might take a little bit of time. So this is a very bare bones example of a UI. Again, we're using Reagent, but you can use whatever you want here. And if you look at what we're logging here, I'm actually inside of the application. I'm logging out the messages. And so you'll see that when we hit when we fire off our request, right, that starts the life of a query. And so we'll get information from that. Artemis will tell us that we started that query. So data will be nil. These are the variables we're sending over. We now know that our request is in flight, and we know that our network is currently in the fetching state. And then when it comes back, we get our next update, which includes our response data, again our variables, and then some changes to the metadata. And all of that information is enough to do this kind of rendering. And if you look quickly enough, you might see it flash. And that's actually a loading indicator that flashes. So loading indicators are super easy to do with something like channels because we just take off the channel. And if our in-flight value is set to true, well, we know that we're currently over the wire and we can just show a loading indicator. And you can use that in combination with some of the other information to do things like send a request over the wire, but also read from a local cache and render that immediately. Again, just this combination of information lets you do basically whatever you want in terms of your UI. And because everything is just going to be a channel, a message put onto a channel, you can interact with every single message in the exact same way, regardless of the information that sits in there. So we remove everything except for working with maps. And that's pretty nice, to be able to just read off a map and understand state that way. I can show the code if anyone is interested in, but I'll just move on. You want to see it? Okay. This is a plain computer, so it won't be pre-printed or formatted or anything like that. So that's the same thing you've seen before, right? We're just logging and we're swapping our reagent ratum, which is going to hold our state. So if you look at our code, it looks exactly like what I showed you before. The only difference is these two lines here. Everything else is the same, and we have a working UI. That's all you have to do. You just have to manage your kind of updates however you want. So again, we're using reagent, so we call swap here, but you could do whatever you want. You could literally change the DOM directly here if you wanted to. You could do it however you want to do it. And that's kind of one of the goals, is we use reagent, but not everybody does. And we don't want to dictate how you might want to use GraphQL. And if you look down here, you can see how easy it is to show something like a loading indicator or an error or anything like that. So this actually says something went wrong. It's supposed to say loading. I was going to do an errors example too. But errors is super easy too, right? You could change this to some other form of logic and say, if seek errors, show an error message or show some sort of pop-up or whatever.